Let's work throughout the Banker's algorithm. The basic idea of Banker's algorithm is that it tests the system when a process requests a resource. It tests the system if this request won't cause a deadlock. Deadlock means that the processes, each one of them has a data that the other needs, and no one can end its process, so everyone is stuck because no one can end, and one depends on the other to end in order to continue. If it doesn't occur and everyone is stuck, so we are getting into a deadlock. Now, Banker's algorithm tries to avoid this situation. So when a process wants resources, it will check firstly if this request, for example, will cause the system to be in a deadlock, and if so, it won't accept this request. So let's see how it works. So here I have resources. You see the resources are available for A, B, and C. I have 3, 3, 2. This is what the system has. Now, this is the system says, this is the processes. We have P0 to P4, and we have the allocation for each process. What is the max demand for each process for resources, and therefore, what is the need? The need comes from max minus the allocation. For example, for A in process P0, there is 0 allocations right now. But let's say the max is 7, therefore he needs 7 minus 0 is 7. For B, he has one resource allocated already. The max is 5, so what he needs max minus allocation, 5 minus 1, which is 4. For C, is 3 minus 0, which is 3. And P1, 2 allocated for A, 3 max for A, so the need is max minus allocation, which is 1, and etc., etc. So this is what the system now has, and let's check if the system state is safe or not. What is safe? If I find a sequence that doing this sequence of doing the processes will let me end all the processes and I won't be stuck. Now, remember that when I end the process, all the allocations come to the resource of the system. So it becomes free, and now the system can use it. So let's start the animation and see. We start with P0. Now, see, it needs much more than what we have. So you saw that we could not do P0 because he need 743 more than what I can give. So I won't do P0 as the first process. I'll go to P1. Now P1 need 1, 2, 2. I can give 1, 2, 2 because I have 3 from A, 3 from B, and 2 from C. So I can give 1A, 2B, 2C. And when I'll do that, I will end process P1. And when this process is done, I will get the allocation, namely I get 2, 0, 0. So I get 2 from this process. Let's see how it happens. This one, it won't be able because there are too many. We don't have it. Here I can do that. So I'll do the process and 2 will get right over here. You saw how A becomes 5 because I get these 2 allocation after P1 is finished. And then we will continue. We will check this process. It needs 6, 0, 0. I have here, after I finish P1, only 5, so I cannot do that. This one I can do, 0, 1, 1, so I'll do that and get, in the end, what allocated to it here. And then let's see what happens. So this one I cannot do because it needs too much, so I won't do it. This one I can, so I'll get 3 to 5. Continue. This one I can't because I don't have 6 in A, so I won't be able. This one I can because I can have this, and then I allocate this, and I'll get these allocations to here. Then I'll try to do this. I have this, so I can do that, and again, I allocated all the thing back to here. Now I can't do that, so I'll do that and get 1B from here. And then I will be able to do that. So you saw that I could do all the processes if I do it in this sequence, and not other, not P0, P1, I won't be able. But if I start with P1, then doing P3, then doing P4, then doing P0, then doing P2, I will be able to finish in a safe state. And this is what Banger's algorithm tests. If I can do that, if I do, So it's a safe state. Safe. This is what it checks. Now let's again see all the animation from the start to the end. And again, we start with these resources and go throughout the processes, trying to figure out if there is a sequence of processes that I will be able to do in order the system not to get into a deadlock and be stuck. So again, the first process to P0, I can't go into P1, I can do that. So I do, and all what is allocated will go to the resources. P2, I won't be able to do. And you see, I start with P1. P3, I will be able to do. I do it, and all the allocated is going right over here. And this is P3 now. Now P4, I can do. So good, I will take this one too here. P0, P4. Now P1, P0 I'll be able to do. Great, I will add it here to the sequence and get its allocations. And P2, let's see final time how the Banger's algorithm work. So I can do P0, going to P1, I can do that. I will start with P1 and allocate to my resources what it did. P2, I won't be able, so no doing it because 6 is more than 5. P3, I will be able to do it and get its allocations to the resources. P4, I will be able to do it. Great. I will be able to allocate what it needs, so I take it. Now P0, I have now what it needs, so I can do that. And P2, I'll be able now to do it because I have 6 here. And great, I'm finished, and this is my sequence. Namely, the Banger's algorithm found that there is a safe sequence, so the system is in a safe state, all process completed. So this is about Banger's algorithm for evaluating to prevent the deadlock in the system to see if the system is in safe state, no deadlock. Again, the need comes from max minus allocation, and this is the resource I have. I just found a sequence that works. Thank you very much. This was about the Banger's algorithm in operating system for preventing, evaluating for prevention of deadlock. That's it.